الآن يمكنكم المشاركة في مبادرة الأيام الرقمية تحت شعار انطلق بقوة مع جوجل، والتي يتناول فيها خبراء جوجل عناوين جديدة أسبوعيا مثل السحابيات، مهارات من جوجل، أندرويد، فلتر، ذكاء الآلة، فايربيس، ديزاين ثينكينج، مقسمة إلى دورات وورشات عمل يومية بالإضافة إلى مسابقات أسبوعية. شاهد الأيام الرقمية مباشرة على اليوتيوب وشارك رأيك وأسئلتك مع خبراء جوجل.
Hello, assalamu alaikum, and good evening. Welcome to another session on the GDG MENA days. Today we're speaking about a new topic in the data sphere. We talk about a tool in Google Cloud, which is data fusion. So we will see how we build data pipelines with the data fusion tool. So we'll introduce the tool. Why is it important? How does it make the job of data engineers, data analysts, developers easy with building pipelines? So straight to the topic, I'm going to introduce a little bit data fusion. What is the history behind it? The features, the architecture. So let's start talking about what is cloud data fusion. And I think so far, this is a really good tool in GCP, but not a lot of people basically leverage the capabilities of that. So what cloud data fusion basically is, a cloud native, fully managed enterprise data integration product on the Google Cloud Platform. But the product itself, Cloud Data Fusion, or we would like to call it CDF, is based on open source. This is another kind of area where Google Cloud are really kind of advocates for open source. Data Fusion is no different. So it's an open source data integration framework called CDAP, a data application platform. And we're going to talk about CDAP a little bit more later. But the focus here is the Cloud Data Fusion. So Cloud Data Fusion basically is an integration platform, is a GUI-based product where you can integrate many data sources and build pipelines from a GUI with a user interface. So you can build your data pipelines using a graphical user interface, and you can perform all the related tasks that you would usually do with coding. So data fusion is completely codeless. And now we mentioned the data integration a couple of times. This is maybe a familiar term with some, maybe not for others. So what exactly data integration means? So firstly, it is a process of bringing together data from different sources. That is the first important part. Now, why are we bringing this data together? It's because we want to create a unified platform. We want to unify all our data, getting kind of more valuable insights, a view out of this data. So instead of having isolated data that is siloed in different places, we want to have all the data in one place to make more sense of it, to get better value from it, so that we can create a better insights, add value to our data. But what is the use of this activity? So basically, we want to make faster, better decisions for the business from different areas. So if we see this in data integration definition, there are three aspects in here. So first of all, bringing data from variety of sources. And because we want to create a unified and valuable view of our data, this is the second point. And thirdly, because we want to make faster and better decisions for our business. So why integrate data? This is another important point. Why exactly we need to integrate this data? So that could be multiple reasons. And as you keep on changing various, you keep looking at different industries, different domains, requirements will be different. Requirements keep changing from one industry to another. And you keep basically gathering requirement as per a specific domain. But if we see some representative causes here, these two are the primary reasons. First one is we want business to take data-driven decisions so that they can perform better in their respective markets. And the second reason, which is again a representative, can be of unlocking higher data value and actionable insights, improving operations. Customer satisfaction is another one that could be improved. And basically, we are in a digital world where competition is fierce. So we want to be ahead of our competitors with insights we get from that. So what is data integration used for? This is another important point. Now, the first area that we can talk here again, these are only some of the areas, obviously, that we mention here. There are many case studies, many other areas that are not listed here, and few of them here. Data lake development. We talked about data lake in one of my previous sessions. So first area that we primarily see when data integration is required is data lake development. Now, as we all know, data lake is a place where all sorts of data can be placed in its original format. So basically what we're trying to do here, instead of keeping data in separate systems and which are spread across different locations, different departments and all the stuff, we are bringing all that data together so that whenever needed, we can refer to this data and we can take this data forward for processing from one place. Second one is for data warehousing. Again, as we know, data warehousing, the data lands up in a data warehouse whenever there is a business case associated with that particular data analysis. Now, it is always better that we can bring different types of data under data warehouse and start processing for different business use cases. Marketing is another one. This is like an interesting domain here. And though I'm not directly from marketing area, but what I can understand here is, these marketing people, they perform various activities in different formats. Like there are some activities which are happening in terms of ad campaigns. There are some activities which are being tracked from web analytics, for example. There are so many social networking channels available where lots of things that are happening about business marketing people, they typically try to gather information about demographics, consumer behavior, how many people they scroll through the websites, which pages they are visiting, what are their comments about, their their feedback, how are they expressing their feelings about products and offerings, or other stuff using different channels. Now, if we see this particular broad domain, we can see huge amount of data is getting generated in different formats. And then if we want to understand whether our marketing policies or marketing strategies are effective or are they doing the job they should be doing, we need to combine all these data together and should be analyzing this particular data. Another one which is very important and basically used a lot these days, IoT. So Internet of Things. Now, as you might have know, Internet of Things is basically collecting sensors or sensor data, and these sensors are spread across many locations, and they send data in real time to business applications. So it gets processed further. So the critical capability here, which we are highlighting about IoT, is capturing this data in real time and then making it available for further business processes efficiently. And then data replication is a central part of any business, wherein you're creating a data warehouse and you're copying data from variety of databases which your business is already using. So say, for example, I've got an Oracle, I've got a MongoDB, Postgres, SQL, whatever, all are being used in our organization. And then there is an application wherein you want to consider data from all the systems together. So in those cases, database replication is considered as data integration capability. Now, at this point, just as important, as equally important, if not more than the other things. But there are other many areas around what is data integration used for. So a little bit of history about CDAP, because CDF or Cloud Data Fusion is based on CDAF. So how exactly this CDF came in existence and what is the brief history behind it. So as we know, as I mentioned in previous class, CDF or Cloud Data Fusion is based on CDAP, which is open source data integration framework designed by this company, Cask Data. IMC, and this Cask Data, who started the CDAP project as open source back in the 2011, sorry, back in 2018, Google acquired Cask Data, and because of that, this CDAP application is now being offered as a Google Cloud product under the name of Cloud Data Fusion. And having said that, after this acquisition, also Google is providing all the support for CDAP in the open source community. Now, what is the beauty of this particular approach? So if you have different opportunity to integrate your applications together, because if you are working on GCP, Cloud Data Fusion is there. If you are, let's say, working outside of Google Cloud, then you can easily use CDAP and you can have data integration available at any other place. Now, one important point we should remember throughout this session here, that whenever we are saying we're working with Cloud Data Fusion, we are creating a pipeline internally. The representation of that pipeline, like we're going to be seeing later on, is to be done using the CDAP standards, the open source framework. So from the perspective, from the standpoint of vendor lock-in and things like that, so you are actually not vendor locked into GCP. You can easily take your pipelines that you're creating with Data Fusion. You can implement CDAP in other areas. So it's, hybrid cloud, multi-cloud, whatever. As long as you've got the CDAP environment, you can take those pipelines and run them somewhere else. Okay, so what does CDF offers? So Cloud Data Fusion, you can build your data pipelines, like I said, using graphical user interface. And I'm going to talk about that. I'm going to show a quick demo of that. So again, it provides different hundreds of plugins. You can connect to different data sources. You can apply transformations, and you can perform different processes on your data. It is also providing like a visual, all those processes through a visual interface. So you're not required to write any code. So it's completely codeless. So anybody who is willing to process the data, they can simply come to this particular UI pretty much, and they can draw a pipeline, deploy it. They also provide thousands of operations to transform your data, ensure data quality and other stuff. And it is an extensible format as well. So if you find your required operation is not listed in the available transforms in the UI, you can always upload or import your transformation into Cloud Data Fusion, and you can start working on it. You can test, debug your pipelines, and you can pre-build your pipelines. It also provides a developer SDK for Java, I think for Python as well, to work with it as well. And what are the benefits of using Cloud Data Fusion? So you can integrate with any data, literally any data source, whichever exists in the universe. So you can have that connector import into Data Fusion, and you can integrate with data source, and there is no coding involved whatsoever. People find it very easy to draw the pipeline and implement them, which basically increase their productivity. Very flexible product, because majority of the components for data integration and processing, they are pretty much available directly from the graphical user interface of Data Fusion. And how exactly pipeline execution and management happen? So it can, you can develop batch and real-time pipelines. So you can bring data in real time. So streaming, pretty much. You can your pipeline runs. You have also what we call pipeline triggers. So you can have dashboards and reporting available, monitoring your performance of your pipeline. You can execute your pipeline jobs using Spark or MapReduce. So you may use Cloud Dataproc for that case on GCP as the execution runner in there, and we're going to talk about a couple of examples in this about the executor of the pipelines. It also provides support to have a private IP. So you kind of, from security perspective, you don't want your pipeline to be publicly available, and also VPC peering, service networking. So you can integrate your pipelines through multiple networks in GCP, and also you can also interact with your Cloud Data Fusion implementation using REST API as well as the CLI. And as of now, I want basically to show you a few of the capabilities we're going to see in the GUI and the demo a little bit later. And another important capability of Data Fusion is metadata. So managing metadata, which is another super important point for specifically data engineers, and basically they always need a tool to manage metadata. Metadata is useful, super useful. You can actually add various tags and properties to your pipeline data sets. Also provides you a way using which you can search for some data assets. And it also keeps track of data set level and feed level lineage. So we take lineage, basically keeping track of all the processes that happen to your records, all the transformation data has undergone, starting from the original source to the current state. So this is what lineage is about. What kind of processes my data has been through. So that could be tracked all through lineage. So a really neat capability here about Data Fusion as well. And it's also extensible. So this is an extensible product. So you can bring in your own pipelines. You can build it. You can bring your own basically plugins. You can bring in your integrations, everything you can upload, and you can extend this platform further with specific kind of items or objects that you can bring to Data Fusion. And this is really, really important here, visualization. So the most probably important slide in this presentation. So I want you to understand how exactly Data Fusion is going to help in these different types of scenarios. So just a minute here or so about the components. You can see here data sources. So considering an enterprise, and basically for data sources, data can be collected from a variety of data sources. So external data, SQL, Kafka, different applications, IoT, software as a service, SAP, for example, SAP HANA, Snowflake, other cloud providers as well, Hadoop. So any of those sources available. So, and you can, this is just like a representation pretty much so, but the list is endless. So the listing available here, there are many, many other sources that we can bring. And also you can basically do both batch and streaming data, databases, application data, flat files, Internet of Things, all sorts pretty much, Hadoop, MapReduce. So data sources list now many, many more what is showing in here. And the second component of this particular diagram is security. So there's a lot of integration, native integration by default with the products, Cloud IAM, IAP, KMS, DLP. So all those kinds of stuff that are available for us to leverage with the Data Fusion product. So this is like a super important, because we're saying Data Fusion is built on an open source product, which is CDAP, but bringing the CDAP platform into GCP, you can integrate with these tools that are available for you to make it more secure as well, because you need data security here as well. And then you can integrate with other things, with other APIs, like the pre-trained APIs on Cloud AI, like Vision API, speech translation. That's, with the click of the button, you will be able to integrate that with your pipelines. And for storage, okay, so we can integrate with Cloud Data Storage, integrate with PubSub, Cloud SQL, BigQuery. So all the storage services we have in here, we can use as source, we can use them as sink or as target. And then obviously the integration with BI tools and AI tools later on to get visualization and dashboards from data fusion. That's also possible. Okay, so many data services in GCP, big data tools in GCP. So when do we use one? Do we always, find data engineer confused to, I've learned a lot in GCP, but when it comes to use, there are multiple products available, which kind of offer similar kind of activities. So this slide typically help us in understanding what are the use cases and when one should use it. So as we can see here, Cloud Data Fusion typically recommended for enterprise data warehouse and data marts, ETL, pretty much ETL developers, data engineers, okay, completely codeless based on the CDAP framework. And basically you can run it on Dataproc as de facto engine, but you can run it on other things as well. It supports only ETL, okay, extract, transform, and load. Data flow, obviously, a lot of coding here. This is specific for data engineers. It does ETL batch supported streaming, but a lot of coding in here. Data engineers who love to code. So this is the main kind of difference between the two. And also you have a data prep product, which usually uses the data lake, prepare data for data lake. Obviously, this one is not a Google Cloud product, but it is integrated there, usually used by data engineers and data analysts as well. So again, just to recap here a little bit, so Cloud Data Fusion, the enterprise data integration platform from Google Cloud. So let us understand exactly what is Cloud Data Fusion does in kind of capabilities. So first of all, the main important point here is graphical user interface. And APIs using which you can create your data processing pipelines very easily with less complexity, so completely codeless. And one more important aspect that I want to focus here is what is the advantage of having fully managed cloud native kind of offering here. So when you say Cloud Data Fusion is fully managed and cloud native, it actually brings in all the scalability, reliability, security, privacy related features that will be managed by Google for you. So as a data engineer or data analyst, you pretty much not kind of have to care really about the underlying infrastructure. So in terms of scalability and replication and maintaining and optimizing the infrastructure that has data fusion, that's all taken care for you. So the focus here of time and energy is to build those kind of efficient pipelines in there. Okay, so how do we launch Cloud Data Fusion instance? So let me just bring in I will just bring my quickly here. Let me stop sharing and I will share my console. Bear with me a second. So there you go. So this is Google Cloud Console. Obviously, we know the hamburger menu here to access resources, but we can get to data fusion from here. So let's see if we first thing first, we need to enable the APIs if it's not enabled. So what we go API, we're gonna search for API services, make sure our API is enabled. So we go to the library, we go to data fusion. So it is enabled, but I'm just gonna make sure that it is enabled correctly. So I'm gonna disable it, enable it again. And I'm gonna enable it again and enabled. And now I can go to create an instance. So that's data fusion. So it's as simple as creating an instance. I'm just going to give it a name, CDF lab instance, just select a region, US Central 1. And I've got three editions. I've got developer. This is for development for sales. It's got like a limited on the execution environment. So this is like for developers to develop the pipelines, zonal availability. So it's not going to have a high availability. So just in one data center pretty much. And then you've got the basic one. Again, more features in here. Connect to any data source, codeless, recommended for non-critical environments again, and it will run only batch. And then you got the enterprise one, which is a fully fledged version. And here, if I want to run real time and streaming, I have to use the enterprise version in here. Okay, so I'm gonna go grant permissions to service accounts at Dataproc. So this is gonna run on Dataproc, and I'm just gonna create. So this is gonna take roughly about between 15, 20 minutes. So we're not gonna be waiting for it here. So what we're gonna do, I'll leave it, running to create our instance for us. We'll go back to the slides, talk a little bit about the architecture, and then come back and have a look at the instance, have a look at the GUI, and create a kind of a pipeline, to see how is it done, how easy it is done from the GUI, connect from data source to some kind of transformation, and then send it to a target source, sync. So let me go back here to and present back. So from the architecture perspective, so this product is managed by Google. So when we say managed by Google, obviously the architecture will look something like this. So, we're not going to go too much of the details here, but we need to understand how is it working under the hoods. So things that we should know when we work with Cloud Data Fusion. So I want you to remember something here. When we create Data Fusion instance, there are many things that are happening under the hood here. So we want to, we have a studio that we're going to be accessing. We have execution of a pipeline that's going to happen. And now what actually happens behind the scene, how exactly different environments or different architecture work with each other. So this slide basically talks about that. So the first component in Cloud Data Fusion architecture is what we call the user space. So the user space, now the user space is basically different ways using which a user can communicate with Cloud Data Fusion API, because all we know, all the services on GCP, they are basically APIs. So Cloud Data Fusion is also an API. Now there are different ways to interact with this Cloud Data Fusion API. One is obviously using the UI, which we're going to be seeing today, which the one that we're going to access when we create the instance. Second, you have the REST APIs, based communication, and third is the command line interface using gcloud command for interaction. So that's basically the first component. Now, this is basically how to interact with Data Fusion API. And underneath that, there will be obviously the CDAP environment. There will be And we have the what we call a customer project, and we have the tenant project. So what is the customer project? So in these projects in which the pipeline is going to be executed, so say for example, we mentioned Dataproc as the execution environment. So for Cloud Data Fusion pipeline, so we've seen that service account that's getting created. So that service account, this is what allows the CDF, the Cloud Data Fusion service, to talk to the Dataproc service. So Data Fusion will have its own service account, and Dataproc will have its own. So this is basically the communication happen between the two services. So where that Dataproc cluster is going to be launched, that cluster will be launched in the customer project. So this is where will be created, and that's where the execution pipeline will happen. So that's the custom project. And then there is something called the tenant project, from where this tenant project is coming in the picture. So this is, we said data fusion is managed by Google. It's fully managed, cloud native, remember, enterprise data integration platform. So we also discussed the fully managed and cloud native means all the operation related activities, all the implementation, all the maintenance, that's going to be handled by Google in the back end. Now, how exactly this is managed in Google? So there is this concept called these tenant project. This is looked after by Google. So now a tenant project is a Google managed project, which will host certain services for us, which your pipeline execution deployment will actually happen. So important point to remember here, tenant project is a Google managed project. The customer project is the customer project. This is where the execution is going to happen. So service infrastructure is used behind the scenes to create a tenant project, and the tenant project, your CDF instance will be created here, will be managed by Google. So if you want to first of all, when we create that instance, the CDF instance that we create in that demo that I showed you, a virtual machine will be hosting a service for CDF that will be basically looked after by Google for you. Now, if I create multiple instances in my environment, how many tenant projects will be created? And the answer is only one project. So I can have many CDF instances, but they will be all under one tenant project that's looked after and managed by Google. So it will allow you to create multiple instances, and all these instances will be tracked inside a single project. So basically, with different instances, you have isolated different environments, but internally, with a tenant project, all the provisions are being made automatically by GCP. So this is the most important point about creating multiple instances here. Then next, we have separate execution environments. So meaning that you build your pipeline using the tenant project based services. So because your UI is available through the tenant project, so using the UI, you draw your pipeline. But when it comes to execute the pipeline, your required execution environment, which is Dataproc, and Dataproc cluster will be launched in your projects. Now, how it will be launched, so whenever you click on the deploy and run Cloud Data Fusion UI, the project will talk to the customer. This project will communicate with each other, will initiate and launch a Dataproc cluster. Then your pipeline will be submitted here from this project to this here to be executed. And there are ways to change the execution environment if we want. It's not just Dataproc. But the main point here is this project has to have access rights to create this Dataproc instance here. And the two main points which are required here to remember is the tenant project is required, and how this tenant project and customer project are going to talk to each other is through service accounts. So the service account here needs to have access and permissions to communicate and create the Dataproc cluster here when we start launching our instance, or when we run the pipeline, sorry. So as different services and components are pretty much interacting with each other, we require some IAM rules. Again, we talked about rules and IAM in previous sessions, so refer back to those if you want details. These are basically how to give permissions to these service accounts. So we can see there is a viewer rule available using which you can simply list or get Cloud Data Fusion instances. And you may use Cloud Data Fusion instances, but if you use admin as your role, then you get full control over your instances creation, deletion, updating, and all the operations. So full control over the Data Fusion instances through Cloud IAM roles, predefined roles. For permissions, again, this is another important point. So different kinds of permissions are really required, and we actually basically going to see that in the demo. So you can see Data Fusion service account is created so that it can basically it can access resources in the customer project. So when you create an instance, there is this basically service account is within the tenant project. Okay, so we need to give access to the service account to the customer project, so that the tenant project will be allowed to launch a cluster in the customer project. So when you submit your pipeline for execution, like we're going to see, it uses the default Compute Engine service account to interact with that particular service. You give it the right permissions, and then the Compute Engine service account will have access and create the cluster in there. And like you saw me there, you have three options in there. So when you create an instance, if you remember from the UI, there are three different editions: developer, basic, and enterprise. So this is just like the different options depending on the requirement. So enterprise gives you the full kind of options in there, especially if you're using streaming, you go for the enterprise version. And a private Cloud Data Fusion instance, obviously, we don't want it to be publicly available as well in there. And connectivity also, if we want to bring in data from on-prem, we can have a VPN connectivity in there. So that's also possible, where we can bring our data sources from on-premises through a VPN, execute that, add it to our Data Fusion pipeline, and execute it on our Datapro cluster. So we can easily, when we have the VPN connectivity, easily connect into external sources as well. Now for the pipelines, again, so basically the pipeline, now that we understand about Data Fusion, what is it? Is a series of nodes, like we're going to see, connected for a flow between two or more places. So you can automate processes for data transformation, for extracting data, combining multiple operations on data sources. Like you can do those transformation, prepare data, and send it for further analysis. And this is how we look like. So when we consider a pipeline, it is actually represented as a DAG, a directed acyclic graph, which is a one-way pipeline in different stages, which you are seeing here. They represent different operations. So you can have data coming from a Google Cloud Storage bucket. You can do a parser here, and you can do you can combine it with another data from BigQuery. You join them together, and then when you join that data, you can also fork out to different data targets as well, like BigQuery in here and cloud storage in here. So you've got many combination of how to do these acyclic graphs. So you represent pipeline as a DAG, and one way kind of a flow that you allow is not, it doesn't have to be linear one after the other. So you do this what we call non-linear pipeline execution if it's necessary, that you have different nodes, different operations, merge data together. So these are all possibilities in there. And again, nodes mentioned here. Again, you have plugins. So how many plugins types are there? There are sources that are transforms, analytics actions, error handling. You can have multiple syncs in there. So kind of there are kind of 6 plugins, and any combination of these plugins is available or are possible in the pipeline: source, transforms, analytics, actions, syncs, and error handling. And again, this is control and data flow. So this is another important concept in the data pipeline. So we'll talk about that, and we'll jump into the console and do create a pipeline that after this one here. So there are two types of flows when you create a data pipeline. When you create a pipeline, one is called control flow, and the second is called data flow. Now, control flow, it is just passes control from one stage to another. So there's no data flow in there whatsoever. So there's no actually data that is passed. It's just, kind of giving kind of a trigger, giving like an intervention that something has happened in that control. In the data flow, actually, data flows from one node to another. So if we consider this particular one here, we got an SFTP is actually working on some secure FTP. Think file. As soon as the file is available in here, it will trigger this particular source. So it will tell, okay, the file is ready. So we're passing control pretty much to the next node. So it will basically, this particular source saying that the file upload is successful, and then the next pipeline operation can start. Basically, I've finished here, you can start your job. So in control flow, we just indicated that some operation has happened, and we have what the plugin is actually being used here is to generate a control flow. This job is not going to start till this job has finished. So it automatically finishes the task, and then it intimates the next node saying that the operation is done. You can start doing further actions. Okay, and then this is a data flow, meaning the data here, it will be passed to BigQuery. Okay, so control flow, data flow, two different things here. Pipeline types. Okay, so both batch and real-time are supported. So batch pipelines, you process data in batches pretty much. So you have a CSV file, you have a database that you bring in. So the pipeline basically terminates. There is a beginning and an end. You can schedule it, you can trigger it. Real-time data that is coming continuously from a messaging bus, from IoT devices. So this is completely different. So when you choose, when you create a pipeline, this is where you create either a batch or real-time. So today we're gonna do a batch, and our next session when we talk about further details about data fusion, we cover real-time, which requires enterprise version of data fusion. Now, which pipelines are valid? So in order to have a valid pipeline, you should have at least one source, and at least one kind of target sink. So sources where data will be read, sink where data will be copied or will be written to. So that is what a valid pipeline. You can have a pipeline where only control flow is passing from one stage to another stage. That's also possible. And you can have multiple actions or multiple action plugins which are placed before or after source and sink. So all these kind of possible combinations here, completely flexible from the UI. So how do we save these pipelines? So how are they represented? So how exactly a pipeline is represented? Now we know that pipeline is actually an artifact. It's like represented is like a JSON file. So I want you to focus on this particular screenshot here. So it is saying that, okay, from the pipeline, we have GCS. It's called GCS to BigQuery. That's the description. So actually, it is a Cloud Data Fusion pipeline. It uses 6.0.0 version. And what is also giving configuration is how much memory is going to be using, how many, this many cores. It's from GCS file to the Wrangler to the plugin where it does transformation. Okay, this is from the previous example. So I can actually save this one, I can export it, and this is how I bring in from other sources as well. So this is how I'm going to be bringing in data or importing kind of data pipelines from CDAP that is running on another environment, or I can export this to another environment. But I do it in the GUI, and then it will be exported as a JSON format. So now we're not generating any code. So we just only JSON specification here pretty much are generated for pipelines, and they are passed down to layers for execution purpose. And this is the beauty about data fusion. It never generates any code for the pipelines. So it's just a JSON representation. This is why people find it more attractive than coding, let's say, in Dataflow or something other environments. Okay, so I'm just conscious of time, so let me just jump into again to the console, and let's have a run of a simple pipeline here. So let me just share my console again here, and so what we'll be doing. Okay, let me log into the console, and okay, so what we're going to be doing, let's have a look at first of all, our Data Fusion instance here. And it is there. It is created, and if I go and view the instance, so let me just run. So this is what it looks like. Let me just there. So this is the UI. You can see how I can have many sources here. I can use the transforms, feed decompressor, field decoder, many transforms that I can use here. Analytics, the group bys, deduplication, the joiner, denormalizer, and then the sinks. I can write back to the sinks. I've got conditions and actions here. I've got error handling, which we're going to be covering in session 2 of Data Fusion. So this one is going to be the basic pipeline. I'm going to bring data from cloud storage, decompose a CSV file into multiple fields, and then write it to a table to BigQuery. And so let me jump back to bring in, look at my cloud storage buckets. I need to go back to so that's my GCP console. Let me just go and open the Cloud Shell. And I'm going to I'm just going to copy some data. First of all, we're going to create a bucket. that in Cloud Shell. So let me just make this a little bit bigger. So I created the bucket, same name as my project ID. So what I'm going to do, I'm going to copy a CSV file called titanic.csv into my bucket. So gsutil-cp, copy from that file into my bucket that I've created. There you go. The file has been created. It's been copied. So it would be, this is my bucket. And that's my file. That's my Titanic file there. So now remember, if I go back to Data Fusion and I'll have a look at that service account that we need to give access to. If you want to execute this pipeline, I need to give access to that service account coming from the tenant project. So if I go to my instance, you can see here I've got this service account. Okay, so that instance is sitting on, remember, on the tenant project looked after by Google. So I'm going to pick up this. So I need to give it access into the customer project, which is ours. So here we go to IAM. And we want to grant access to this account to our Data Fusion. So we're going to go Data Fusion API Service Agent. Our Data Fusion API Service Agent. So we're giving access to the API through those permissions. And then I need to give to the compute engine. So if I go to my service accounts, I've got the compute engine or default service account. I need to give permission to the service accounts. So this one here, if I go to Cloud IAM, if I go back here, this one, Cloud Data Fusion API, this one. So this service account, I need to compute engine, I need to give it permission, grant access, so we can create that instance. We can create compute engine instances as part of the Dataproc. So here I need to give it service account user. There, save that. So now I should be able to go and create a pipeline. So what I'm going to go back to my Data Fusion instance. Sorry, I keep changing the tabs here. So in here, what I'm going to do, I'm going to bring as a source, we're going to bring in cloud data storage. And from cloud data storage, we want to then choose the wrangler. And we want also to bring BigQuery into the equation as well. So here I want BigQuery as a sink actually. And here, so this one here, if I look at the properties, for the properties in here, I want to the reference, so down here, so on CSV. So the path, I need to get the path of my cloud storage. 1 second. And the reference, validate that. Okay, close that. And then here, for the Wrangler, what we want to do, let me just get the properties here. Close that. And for BigQuery, let me see if it's going to bring that. So for BigQuery, the dataset project ID, there you go. Reference table. Okay, that's fine. It's gonna create it. So if I do preview, gonna run this. Enable path BigQuery. Okay, configuration for BigQuery is wrong. Let me just have a look here. What is missing? Let me check this preview data here. So it hasn't brought any data. So the GCS demo, auto detect CSV. Okay. And then this one here. For the wrangler, maybe this is the issue. Just pick up. Okay. Okay. Okay, let me just quickly go back here to instance. Going back to my data fusion. Just checking permissions there, not picking up the data. Okay. Let me check, share again. So this is our passing. We want to do text from that file, that Titanic CSV. We want to bring as text. Confirm that. So this is our data from the CSV file. So you can see here is just the full field here. So what we want to do, we want to pass it. So we go pass as CSV. And we want to do it based on the comma. So now this field is now into this different field. So we pass it into different fields. So now this one we don't need. We can delete that. So that's what we want to create. So this is the transformation that we are doing for this file. So we can create a pipeline from here as batch pipeline. And so here, our GCS file, that's our file in here, our path, that's all good, validate. And then we bring as a sink, we're gonna bring BigQuery. And for BigQuery, we're just gonna specify the data set and the table where we want to transfer that. Close that. And this is what we want to write the data to. And if we look at the Wrangler details, it's already created for us. So it's passing that the body into these fields. So if we want preview, make sure no errors now. So now our data came as text file, turned it into CSV, into different columns. The Wrangler is doing that transformation for us. So if I preview the data here, so if I do preview, so let me run first. It's going to generate the data for us. So it's giving me okay, that's fine. Run. Why? A dataset name. you go. So we bring in our file from Google Cloud Storage bucket as a text. We read the transformation into those fields, and then we are writing to a BigQuery table. And this is like a batch pipeline. You can see here, a batch pipeline here. We picked up the source, and then the sink where we're writing, and the transform, which is the wrangler, is doing that transformation for us there. So it's completed successfully. If I look at the data here, this is my original data, my comma delimited. And if I look at here, what it turns out to be those fields here, we divided it as per commas in here. And then that's the data, how it is in BigQuery. So here, I didn't write any SQL statement, I didn't write any code. It's just basically the UI, bringing those pieces in there, source, destination, what kind of transformation. So basically, this is simple one. It could be a complicated one. So hopefully, in our next session, we talk a little bit more about streaming pipelines. We do more advanced pipelines in there. So that's it for that demo. So this is basically our first session of data fusion. Let me see if there's any question that were in the chat. I can't see anything. So thank you very much. If there is anything, please, you can reach out to me. I think my colleague is going to put, we have a question. Okay, what's the question? Let me see. Can you put I can't see the question. Can you put it in the? Yeah, data fusion is included, is part of the data engineer exam. Yes, definitely in the data engineer exam. As for maybe the architect and the ACE, not as much. You just need to know what does data fusion do, pretty much. Okay, if they give you a use case, what is the easiest way to create pipeline or something? Data fusion is there, codeless, GUI based. But data engineering, you need to know more than that, obviously. All right, if there isn't any other questions, thank you for being with us today. And I will see you in our future next session, Data Pipelines, Data Fusion number 2. Thank you so much. Have a good rest of the weekend. Have a nice evening. Assalamu alaikum.